Welcome back. Now we're going to solve an angle side angle triangle. So we know two angles and an included side. And if we're ever dealing with angle side angle or angle angle side, that means we can use the law of sines to solve for the missing angles and side length measures of the triangle. Here we have an application problem. Let's read the problem first. A ranger in Fire Tower A spots a fire at 295 degrees. Another ranger who's in a different Fire Tower B, which is located 45 miles away in a direction of 45 degrees from Tower A. So we built these two fire towers. We know where they exist. We placed them. We know their measurements and orientation to each other. So we know this 45 and this 45. So that guy who's in the same tower, in Tower B, he spots the fire at a direction of 255 degrees. So how far is Tower B from the fire? All right, so we got to set this up. And there's an important thing for us to note or remember when we are dealing with navigation problems using a compass. Pilots often navigate like this. Ships navigate like this as well. We navigate clockwise from north. So north is going to represent 0 degrees. And clockwise means we move around to the right around that triangle to reach 360 degrees. Okay, so when we're navigating, we navigate degrees off of north, moving clockwise. And that differs from what we have formerly learned when we started talking about the unit circle. We said that 0 was our positive x-axis and we rotated counterclockwise to get to 2 pi or 360 degrees. So in this problem, when we are navigating, we're going to navigate clockwise off of north. That means when I deal with this measure 295 and this measure 45 degrees and the measure 225 or 255, I'm sorry, all of those measures are going to be created clockwise from north. We also have a little piece of geometry that is going to help us. And this is when two parallel lines, if they are cut by a transversal, so that's the line passing through them, the alternate interior angles are going to be congruent. So this is something that helps us to determine angle measures. Alternate sides in between the two transversals, alternate interior, those are going to always be equal as long as our lines are parallel. So let's start drawing. I'm going to give myself some space for this. Here is Fire Tower A. I'm going to call it A. And so the ranger's in the fire tower and he looks off in an angle measure of 295. How am I going to measure 295? So 295, we have to remember, navigate clockwise from north. 90, 180, 270, 295 gets me over into this quadrant. So 295 degrees takes me over there, and he looks out and he says, okay, this is where I see my fire. Somewhere over here. Call that F. There's my beautiful fire. Okay, so we've looked off. That is 295 degrees that we've measured there. What does that mean for this smaller angle here? Well, 0, 90, 180, 270, that means this little angle here is 25 degrees, and that might be helpful to us later. Also, we might think, well, what is this smaller angle in here? Well, actually, it's not smaller, it's larger. But what would that angle measure be between north and this vector, in a sense, that I've drawn from A to F, or ray? And that would be 65 degrees, because I know that 25 and 65 are complementary angles. They're going to add up to equal 90. Okay, so let's think about where Tower B is. Tower B is 45 miles away in a direction of 45 degrees. So again, when we measure that 45 degrees, we're going to go off of Tower A. We're going to go north clockwise. 45 will end up right in the middle, right about here. So we're off in this direction. And my picture is not drawn to scale, but I have Fire Tower B. We know the length of this is 45 miles. We know this angle measure from north, off of north to that ray or vector I've just drawn, there was my north, is 45 degrees. So as we deal with these navigation problems, we're always going to be recreating our compass at each of these points. So one thing I know is that this angle between north and this ray I've drawn, AB, is 45. Well, that would mean then up here, this alternate interior angle would also be 45 degrees. So alternate interior angles, 45 each. All right, so he looks out, our last piece of information here, and he spots that same fire, but the direction he's looking on his compass is 255. And we're traveling, or we're rotating from north. 90, 180, 255 is a little bit past right here. And when I draw my line from B to F, now I have created a triangle. I have triangulated the fire. All right, so we have some angles to think about up in here. I know this angle's 45. This line that I just drew, it's below 270. We went to 255. And so if we think about that being below, this guy's 270, we have this little sliver in here, up here at the top. That would be 15 degrees, because that's 270 take away 255. There's my 255. Went around and up to that point. Now, what then is the angle measure between the line AB and BF? What's that angle measure formed by those two line segments or rays? Well, if I know this little piece is 15 and this little piece is 45, then I can add those together. 15 plus 45 is 60. That lets me know that this angle measure is 30 degrees. And that's because all three of those angle measures, 15, 45, and 30, they all need to be in that 90 degree in the third quadrant here of my compass. All right, now we have a lot of information that we have detailed out. I like to extrapolate my triangle I've just drawn. I'm going to draw it about like this, try and make it look the same, but it doesn't have to be perfect. We have A, we have B, and we have F. And the side that we know the length from A to B is 45 miles. Do we know any angle measures? Well, we just found angle B. Angle B is going to be 30 degrees. And what about angle A? Angle A is between these two lines. 65 plus 45 gives me 110. So now, looking at what I have an angle, side, angle, triangle. Angle, side, angle, or angle, angle, side, we can solve the same way. So I went over how I drew this in my setup very carefully because I want you to have practice with that. In your homework, you'll need to do this. On your test, you may need to draw a picture like this. And the only way to get better is to practice doing it. All right, now that we have our triangle, let's solve. And what are we being asked to find? We're being asked to determine how far is B from the fire. So that means I'm being asked to find the side length from F to B. And if I were labeling that in terms of triangles, that would be side A. Side A is our unknown. How about the side from B to A? What would we call that? That's opposite angle F, so we'll call that little f. So if I use my law of sines to find this, I need, well, A over A. I've got an unknown. I would either need B over B. I do not know, little side B, or F over the sine of F. What is the measure of angle F? Angle F we can find by saying, well, I'm going to take 180 degrees and I'm going to subtract the two angles that I know, 30 and 110, which gives me 40 degrees. So angle F is 40 degrees. Side F is 45. We know that angle A is 110. Now we have enough information to set up our law of sines. So setting this up, I'll say F over the sine of F equals A over the sine of A. Or 45 over the sine of 40 equals little a over the sine of 110. Of course, from here, we cross multiply. So that is 45 times the sine of 110 equals a times the sine of 40. Divide on both sides by the quantity sine of 40. And we have 45 times the sine of 110 divided by the sine of 40 equals a. And with a little bit of calculation, I encourage you to type that into your calculator. You get that the side of little a is 65.785599, or we will say tower B is approximately 65.8 miles from the fire. So now they have used what they know and the measurements from where they've seen it. They took their data, pulled it together, and said, all right, well, we know exactly where to send the helicopters full of water. So there's my answer. Always be careful when you are rounding on My Math Lab to make sure you look at the decimal places requested. But we found this length here from F to B, from fire tower B to the actual fire F. That was approximately 65.8 miles away. I hope that helps you understand how to set up some of these navigation application problems. And then in regard to the computation, as you probably noticed, once we've set it up, that computation's very, very simple. So in conclusion here, we solved angle side angle using the law of sines. And if this had been angle angle side, it would have been very similar computation. As always, email me if you have any questions.